Hello friends, today I will discuss about capacitor bank size calculation for a substation. Before going through this video, you can go through my channel and do subscribe my channel if not subscribed earlier. Capacitor bank in a substation is used to improve the power factor of the system. Now what is the power factor? Power factor is defined as the cosine of angle between voltage and current. If V is the voltage and I is the current and theta is the angle between voltage and current phasor, then power factor is equal to cos theta. Again, for a power triangle, that is if active power is defined by kilowatt and reactive power is defined by kVAr and apparent power is defined by kVA, then power factor can be defined as the ratio of active power to the apparent power, that is equal to kilowatt by kVA. Now what are the disadvantages of poor power factor? For a three-phase circuit, line current is equal to P by root 3 B cos theta, where P equal to active power drawn by the load and B is the line voltage, I is the line current. So it is clear that line current is inversely proportional of the power factor. If the power factor decreases, then line current will increases. If power factor is close to unity, then line current will decrease. Now line loss is equal to I square into R, where I is the line current and R is the resistance of the line. So line loss is directly proportional to the square of the line current, and line current is inversely proportional to the power factor. So we can conclude that line loss is inversely proportional of the square of the power factor. So consider the power factor as 0.8. Therefore the line loss at 0.8 power factor will be equal to 1 by 0.8 square into that of the line losses at unity power factor. So we can say that line loss at 0.8 power factor is equal to 1 by 0.8 square, that is equal to 1.5625 times that of the line losses at unity power factor. So if the power factor decreases from unity to 0.8, the line loss will increases 1.5625 times. Again, consider the power factor as 0.7. Then line loss at 0.7 power factor will be equal to 1 by 0.7 square into line loss at unity power factor, which comes as equal to 2.041 times line loss at unity power factor. So if the power factor decreases from unity to 0.7, then line loss will be almost double that of the unity power factor. Now since the current increases due to poor power factor, there will be more voltage drop, that is voltage drop in the line will increases. So terminal voltage in the load side will decreases. That will result in poor voltage regulation of the system, and that is why most of the utilities impose penalty for poor power factor for the consumer. A load megawatt is given, that is active power of the load is given, and the initial power factor of the load is cos theta 1, and this power factor is to be improved to the final power factor, that is equal to cos theta 1. So what is the value of the capacitor bank required? We have to calculate by means of these three data. So known quantity is initial power factor, that is cos theta, final power factor cos theta 1, and the load in terms of megawatt, that is so we have to calculate the value of x. So x is the size of the capacitor bank required in terms of megavar. Now for the triangle ABC, the initial megavar drawn by the load is given by BC, that is BC by AB. BC by AB is tan theta. So BC equal to AB into tan theta, that is megawatt into tan theta. And for the triangle ABD, the value of the BD, that is after the final power factor, what is the reactive power will be drawn by the system, is equal to megawatt into tan theta 1. So the value of the X, that is DC, is equal to BC minus BD. Now BC is equal to megawatt into tan theta and BD is equal to megawatt into tan theta 1. So X equal to MW into tan theta minus MW into tan theta 1. Now let us consider an example where load is taking the active power in 10 megawatt and the initial power factor is 0.75 and we want to improve the power factor to 0.95. So what is the capacitor bank size required for the load? So here the cos theta is 0.75 and cos theta 1 is 0.95 and the value of AB equal to 10. So X equal to 10 into tan of cos inverse 0.75 minus tan of cos inverse 0.95. Now cos inverse 0.75, that is the value of the theta, is equal to 41.41 degree, and cos inverse 0.95, that is the at final power factor 0.95, what is the power angle? That is angle is 18.19. So 10 into tan of 41.41 minus tan of 18.19. So the requirements of size of the capacitor bank equal to 10 into 0.882 minus 0.329, which comes as 5.53 megabar. So we can see that for a load of 10 megawatt, if the power factor is to be improved from 0.75 to 0.95, the size of the capacitor bank required is 5.53 megavar. That is almost 50% of the active power drawn by the system. So friends, this is how the capacitor bank size is calculated. So thank you for watching my video.